Hello, good day, guys. Today we will be solving a quadratic equation by using the completing the square technique. Okay, but first things first, we need first to establish, okay, that in this case, this is the standard form of a quadratic equation. Okay, as you can see, it is expressed as ax squared plus bx plus c is equals to 0. A here is the coefficient of the variable x to the power of 2. B is the coefficient, the constant coefficient of the variable x. And then C here represents the constant, okay, of the entire equation. I guess that's all. So how about we move on very quickly to the examples. Okay, let's go to our first example. In this case, okay, what's our A? A, as we have said before, is the coefficient of the variable x to the power of 2. And in this case, it doesn't have 1, right? But automatically, that's 1. That's according to mathematics. It's not 0, but it's 1, if you don't see anything there. And then B is the coefficient of the variable x. In this case, the coefficient is 8. And then the constant is 12. Okay? So I hope that's pretty much clear. Okay, let's do this step by step. 8x. The first thing to do is you isolate the constant. In this case, the constant is 12. Isolate, meaning transpose it to the other side, to the right side of the equation. So since it's plus 12, you transpose it, it becomes minus 12 or negative 12. Okay? And then the next thing to do is this. If you've noticed, your expression, your algebraic expression at the left side now only has two terms, and you need to create a third term. How to do it? This is how to do it. All you need to do is you just divide the coefficient, the big coefficient, okay, the coefficient of the variable x by 2. And in this example, the big coefficient is 8. So you divide it by 2 and then square it all together. Raise it to the power of 2. Easy as that. And then you have minus 12 on the other side. Okay, so as to balance things out, okay, so as not to change the value of the entire equation, whatever you did to the other side, to the left side, you also have to do it on the other side so that everything just balances out, okay? And by doing this, you did not change. You only change the form, you did not change the value. So x squared plus 8x, okay, you get 8 over 2, that's 4 raised to the power of 2, you get 16, right? And then 12 plus, that's also 16. Okay, if you factor this one, you will get a perfect square. So that's x plus 4 to the power of 2. Okay, automatic. That's it. Negative 12 plus 16, you get 4. Okay, let's just transfer that one here. Okay, we are interested of solving the x, so we need to get rid of the 2 here first, the exponent, and to get rid of the exponent, we just have to get the square root of both sides. Okay, clear? So that becomes x plus 4 is equals to, since we get the square root of both sides, we need to consider two values, okay, the positive and the negative values. So that becomes now 2. So all you need to do now is just solve the value of x. It's positive 2 here. On the other side is the negative value. Okay, and then just solve for x. 2 minus 4. 2. Okay, we now have solved already one value of x. All we have left now is this. 4, when you transpose it to the other side, that becomes minus 4. So negative 2 minus 4, that's negative 6. So those are the two values of x in this particular example. Okay? Let's move on to the next example. Okay, the next one. X squared minus 2x minus 4/8 is equals to 0. Okay, all you need to do Again, is just isolate or transpose the constant. In this particular example, the constant is 48, right? This is minus or negative 48. When you transpose it to the other side, it becomes positive. Okay. Again, you only have two terms left here, but don't worry, you need to create a third term. How? What to do? You just divide the b coefficient by 2. Okay? So it's 2 over 2 and then raise it to the power of 2. All right? By the way, your third term, the sign will always be plus. It's always positive. Okay? There's no way that this is going to be negative. And then 48 and then plus 2 over 2 square. Right? That's 2x plus 2 over 2, that's 1 raised to the power of 2. That's same thing, it's 1. So this is now 48 plus 1. Again, you now have formed a perfect square, which is actually our purpose, okay, of doing it. That's why we try to do it by completing the square. So x minus 1 squared is equals to 48 plus 1, that's 49. And then once again, you get the square root of both sides. Then you now have x, instead of x minus 1 squared, you get the square root of it, so you only have x minus 1 left. Okay? And then square root of 49 is 7, but since you get the square root of it, you always consider the positive and the negative value. So it's plus and minus 7. Okay. So the only thing left for you to do is to solve for x by considering the two values. Okay? Solve for x, transpose the minus 1 to the other side. This becomes 7 plus 1. So x is equals to 8. All right. And then this one becomes minus 7 plus 1. So negative 7 plus 1, that's negative 6. Once again, we now have two values of x. That's 8 and 6. Okay, how about going to our third example? Okay, x squared minus 3x. Again, just transpose to the right side the constant. So you know how equals positive 28. And then create a third term by dividing the b coefficient. Which one is the b coefficient? It's 3. The one that I underlined, right, is 3. So that becomes 3 over 2, and then you raise it to the power of 2. 28 plus whatever you did to the left side, you're obliged to do it to the right side as well. 3 halves squared. Okay, easy, right? So x squared minus 3x plus 3 halves to the power of 2, you have 9 over 4. Yeah. And then is equals to 28 plus 9 over 4. Okay. X squared minus 3x plus 9 over 4 minus 3 halves. That's a perfect square. That's x minus 3 square is equals to 28 plus 9. Get the least common denominator, which is 4. 4 times 28, you get what? That's 112 plus 9. Okay? So you have x minus 3 halves to the power of 2. 112 plus 9, that's 121 over 4. So you have x minus 3 halves, 121 over 4. To get rid of the exponent, we get the square root of both sides. Okay, so you have now x minus 3 halves. Square root of 121 is 11. Square root of 4 is 2. Again, get the plus and minus sign. Okay, We now have two values of x. So x minus 3 halves. I'm sorry. You have x minus 3 halves is equals to 11 over 2. And you also have x minus 3 halves is equals to negative 11 over 2. Okay. Transpose 11 over 2. This is minus. This becomes positive on the other side. So 11 plus 3, that's 14. Divide by 2, you get 7. Okay, we now have solved already one value of x. We only have one left. 11 over 2, again transpose, this becomes plus 3 over 2. Negative 11 plus 3, you have negative 8 divided by 2, it's negative 4. Okay. Okay, folks, we have solved already the two values of x in this particular example. Okay, we now have solved already 3 examples, right? Okay, let's move on to the last example, the fourth one. Okay, very quickly. This is a lot easier now, right? After doing the 3 last examples. Transpose this one, the constant to the other side is minus 6. This becomes now positive 6. And then x squared minus 2x. And then what? Create a third term. How? By dividing the b coefficient, which is 2. So that becomes 2 over 2 to the power of 2. 6 plus 2 over 2 to the power of 2. Okay. X squared minus 2x plus 2 over 2, that's 1. When you square it, it's the same. That's 1. 6 plus 1 as well. Okay, we now have arrived into an expression which is actually a perfect square, okay? So this is now x minus 1 squared. 6 plus 1 is 7. Okay. So what to do next? Get rid of the exponent. So we get the square root of both sides. What will happen? You get x minus 1 is equals to positive negative square root of 7. Okay. 7 doesn't have a perfect square root, so leave it as it is. Okay. So all you need to do now is actually just solve for the two values of x. You have x minus 1 is equals to square root of 7, and x minus 1 equals to negative square root of 7. Okay, and then x equals to 1 plus square root of 7, and x is equals to 1 minus square root of 7. Okay, those are the two values of x. Okay, that's all, folks, and I hope I was able to help you understand how to solve quadratic equations by using the completing the square technique. And if you believe that you need more examples like this one, just please drop your comments in the comment box below so that then I may be able to prepare other examples for you. That's all, folks. Bye. God bless.